Caleb Scharf. It's great to be with you today. Thanks so much for joining us.
Oh, thanks for having me.
So, you recently wrote a piece for us about a new proposal for contacting intelligent alien life. Is there anything unique about this latest attempt at communicating with potential beings in our galaxy? Maybe you can give us some historical context.
Yeah, so this latest idea, and it really is just an idea, a proposal for a way to message extraterrestrials, is not truly unique. It's kind of an updated version of a strategy that people have talked about before, and it's to do with transmitting radio signal, but it's a lot of it is to do with the specific structure of that signal, a design, if you will, for carrying information in a way that might be decoded by another species out there, and presumably an intelligent species that has mathematics and physics at its disposal, so it can interpret what the message is trying to convey. And so the interesting thing about this is that it's a it's an idea that's been around for a very long time. It's an idea that actually certainly predates technological capacity to transmit radio waves or other forms of electromagnetic radiation. People were thinking about this, a good couple of 100 years ago, but in a variety of different ways. So going back far enough, you get to a point where people were interested in whether or not, for example, something was living on Mars or Venus, and how would you communicate with those other species? And so we had all sorts of interesting historical thought on this, some from people like the famous physicist Gauss, who at least anecdotally thought of manipulating forests in Siberia and making enormous patterns on the surface of the earth that represented things like the Pythagorean theorem of triangles, with the rationale that if someone was looking at us from a distant planet through their telescope and they saw this very geometric pattern that corresponds to a specific mathematical theorem, that they might conclude that there was an intelligent species on that planet that might be worth talking to. And ideas came and went over time. There are other slightly more dramatic ideas that involve focusing the sun's light onto, let's say, the surface of Mars and actually burning a message into the surface of Mars, which seems like an incredibly invasive thing to do. But then, of course, with the rise of our own technology and our own technological capacity to transmit signals using radio waves, people came back to this idea. People like Nikola Tesla was actually somewhat interested in this, or at least in terms of whether he could receive signals from other species in our solar system. But these very early ideas about transmitting messages to extraterrestrials were just kind of vague. I mean, they seem like a good idea, right? You want to talk to another species, so let's do it. And of course, they'd recognize some mathematical structure, but they might just, maybe they could understand English or French or whatever language we utilized. It wasn't until really the middle of the 20th century that people started to think more seriously about both, is this a good idea to do this at all, and more sort of thorough, detailed investigation of what would a first message look like? What should it contain? How would it be interpreted? Can we design something that lends itself to interpretation by another intelligence? And so, really, this most recent proposal coming out of some scientists at JPL and Caltech and other institutions is sort of a progression of that idea. So it's a sort of a thought experiment, and it comes along with some strategies for, let's transmit it towards the center of our galaxy because that's a good place to send messages. A lot of stars there, perhaps a lot of planets, and so on. So that's kind of the potted history of some of this.
What sort of details do they propose to put into this message that potential aliens might receive?
Yeah, so it again it sort of um, builds on earlier ideas. Back in the 70s, there was a famous effort, the so-called Arecibo message, that kind of began this sort of approach. The most recent idea is that information is encoded in what are effectively little images, so 128 by 128 pixel images, in effect. And those images can contain, number systems represented by various patterns. They can contain information about the molecules that go into life on Earth. So nucleotides and the structure of DNA, and of course other mathematical um, relationships that sort of tell you perhaps, oh, this is the thinking species, and it has a certain level of mathematics. I think some of their other ideas for incorporation into the message is to do with basic physics, but also identifiers. This is the solar system. We are here. This is what the solar system looks like. This is what we look like. Sort of indications of our anatomy and physiology and so on. All the kinds of things that sort of first date you want to get across. Yeah, I'm human, and I'm sorry I've only got two legs, but that's how it is. It's that kind of thing.
So, one question you could wonder about is how would we put this information in a way that could be understood by a species? We have no idea how they understand language or what their means of communication are. But another question is whether it's prudent to send information about, for instance, where we are located. I mean, how is that a foolhardy thing to do? What have the proposers of this idea given any thought to that?
Yeah, it's a great question. And it is something these most recent proposers, the scientists who put this most recent idea together, do sort of talk about a little bit. They've written a journal article that describes this idea. Um, and because people have pointed out that this could be a really dumb idea, right? This could be announcing that you're here for the taking, that you're a naive enough species to announce your presence, to give away where you are, to give some indication of what you have. Not necessarily in terms of natural resources, things like water and metals and so on are abundant in the universe, but we have this planet that is rather good at sustaining life, and that may be quite an unusual thing, and that could be a tempting kind of resource for another species. So people like Stephen Hawking and others have pointed out the potential danger of announcing your presence in the universe, and more extreme versions of um, that caution include ideas like so-called dark forest hypothesis, which is sort of taking that to the extreme, that it's not so much that aliens are going to show up and take what you have, but aliens are going to be paranoid, and they're going to suspect that they don't know what you're going to do, and so the most prudent thing is to eliminate it before you do anything bad to them. So the authors of this most recent study bring that up. They tend to skew towards the side of this argument, which is that any species capable of receiving this message, technologically advanced enough to understand it and even to do something about it, is surely a species that has figured out how not to destroy itself. And so they state that that kind of species is likely to have overcome its self-destructive tendencies, overcome its aggression, learn to manage its planet, and so on. So, in other words, they would most likely be long-term, surviving, peaceful, curious creatures, whatever they they look like. Now, it's really hard to know which argument is correct, and it may well be that both arguments could be applied in different circumstances. But really, the deeper piece of this, and I think you kind of alluded to it, is just knowing what another intelligence would be like, another technological intelligence would be like, is a real shot in the dark. We have our one example of us, and we're this, as far as we know, the one species in 4.5 billion years on Earth that has got to the point where it can manipulate the world in the way that we do, and build technology, and to utilize information, and to think at the level that we do. But that doesn't mean that's the only way that can happen, that there aren't other flavors where things that we hold dear, like mathematical theorems, could have a completely different meaning. They might still be utilized, but they could have, cultural meanings. They could be, religious items, right? Pythagoras's theorem could be heralded as seen as a religious item that, if someone else is displaying, that's blasphemy, right? So we just don't know. We just don't know.
Is there any value in this project as a science project? Like, what is the scientific objective in this endeavor?
Well, it's a good question. And I think, in fairness, there is something to the intellectual exercise of how would you announce your presence and communicate with another mind, or another kind of mind. And it's something people have also thought about, obviously, here on Earth. We get interested in communicating with other creatures. It could be dolphins, it could be the octopus, it could be, your cat or your dog. And you immediately come up against some pretty serious barriers, because you don't know what's going on in those other minds. So I think, as an intellectual exercise, there's definitely value to it. There's also some value to figuring out how to construct a radio transmission that will retain its integrity, both in terms of the actual signal itself and the actual process of transmission, but also in terms of the information that it contains. So it's kind of redundancy built into the message, so that even if some part of it gets corrupted, you'll still be able to decode that there's something interesting there. And that actually could be important, for our own exploration of the universe. If we push further and further out into just our own solar system, or further beyond that, the ability to transmit information robustly, especially complex technological information, is going to be really important. And while we have certain tools for that already, from telecommunications and things like information theory, I think there's no doubt there's still some room to come up with clever ideas, clever ways of identifying ourselves to ourselves. Especially if we're out there in space listening to all sorts of radio noise.
At the beginning of the piece, you mentioned that parents rightly caution their children from talking to strangers. And this is like a sensible thing because, you know, even though the chances aren't so great that something bad would happen, if something bad does happen, it could be really bad. So, best to avoid that sort of thing. But why is it that when it comes to the fascination we have with communicating with aliens, we don't really apply this rule of thumb?
Yeah, it's I use that idea to start the article off, because it just occurred to me that, yeah, we have these rules amongst ourselves. There's this absolute caution about strangers. We're really careful about that, and particularly with our children who've not yet, learned that maybe not everything is the way it seems out there in the world. It's quite hard to know why that often gets that idea of caution does tend to get abandoned when we talk about messaging extraterrestrials, building these messages to contain really quite personal and revealing information. And I'm not quite sure what that is, what goes on there. I think, it's optimism, perhaps, which is a lovely thing. And of course, the whole exercise of SETI and messaging extraterrestrials has a lot of optimism in it. It has to, by its nature. Um, but I think it's also, you know because we have this preconception that the chances of success, either of hearing aliens or successfully contacting them, feels like it's going to be so remote, the chances of doing that. And of course, that itself has all sorts of biases. We really don't know how remote that chance is. But I think even people who are enthusiasts have this sense that, well, yeah, who cares really? I mean, is it really going to work? Right? So let's just. But it's an interesting intellectual exercise. Um, but we don't know. We really don't know. And so I find myself veering between the two viewpoints. On the one hand, it's fun to think about these things, and maybe we can learn something about ourselves by going through this exercise. What is most important to us? What does express the nature of us best if we wanted to tell something that has zero experience of us? But like the cautious parent, the other part of me, little bell rings and says, well, yeah, you probably, you shouldn't, the potential for something to go seriously wrong here is can't be excluded. And so we should probably think further about this.
Do you think the um, the way we think about the impact of the future also matters here, where we kind of downrake the importance of the consequences that would come to future generations, because it would be future generations far ahead that would experience a kind of bad consequence of an invasion or something. Maybe that also plays a role where it's not going to happen to us, so let's give this a shot.
Yeah, it's a great point. And I think at some level that absolutely comes into this. Um, I mean, I suspect the people who spend time constructing these possible messages for transmission perhaps aren't thinking too much about that. But the truth is, yes, you could send a message, even if it's to a star, let's say 10 light years away. The earliest you possibly get any kind of response or consequence is 20 years later. Right? The message goes out for 10 years, and if there's an immediate reaction, it'll take at least 10 years to get back to you. And that's quite a way off. And as a species, we know we're not very good at planning even that far ahead, which isn't, it's not a century, it's just 20 years. Um, so I think, yeah, that does, it mutes a bit of the anxiety over this, because it feels like, yeah, well, let's send a message to a star 1,000 light years away, because we're not going to be around to hear any response. Um, but that could be seriously um, mistaken, as we know, in terms of what we're doing in our own planet and the way that we have a hard time foreseeing or accepting future consequences of actions today. This could certainly be up there with, in 20 years' time, after you sent your message out and you forgot about it, in 20 years' time, when you've retired and are sitting on a beach somewhere, the alien mothership suddenly descends and starts eliminating us, all because 20 years ago you thought it would be cute to send a message out there. Now, I personally don't think anything like that would happen, um, but even transmitted information has the potential to be extraordinarily disruptive. So we don't know what that response 20 years, 40 years, 100 years down the line would mean for us. And I've thought about this before, and information can be dangerous. Okay. And especially because of what we read into information. In a sense, information can be weaponized. If it says, we're going to come and eat you now, by the way, what do we do then as a species? We might debate and say, well, no, they're not really going to travel 100 light years to come and eat us, but we don't know for sure. So we better do something about this. And so we could spend generations changing the nature of our society, expending resources, all in preparation for something that might never happen. It might just be another species getting rid of us by sending us sort of weaponized information to remove us from any sort of bothersome role in the future.
Right. Do you think the galaxy might be teeming with life out there, intelligent life. How do you size up all the different estimates of things like the Drake equation, which try to parameterize different variables to come up with the best guess of what's most likely the case for life in the galaxy?
Well, it's difficult. The Drake equation, is a very useful tool. I think one has to be cautious about reading too much into what you get out of it because it's not really a predictive tool. It doesn't have any sort of underlying principles to it. It's more of a sort of evaluation of the different factors that could conceivably go into setting that number of other intelligent species, technological civilizations out there in the galaxy. My personal feeling, as I'm in astrobiology, I think about these things a lot. I think it's possible that there are a lot of other species out there that are as sophisticated as we are on Earth. I mean, sometimes it's hard to see humans as very sophisticated, but we are. We're a very extraordinary species. There really is no getting away from that. Um, I don't think we've seen anything yet in our understanding of the nature of planets, the nature of star systems, the qualities of environment out there that might predispose them towards any kind of life or even more advanced life. I don't think we've seen anything yet that says we have to be very rare as an intelligent species. Um, the flip side to that is we've of course not had any success yet with SETI, with the search for extraterrestrial intelligence. But we also know that despite thinking about that and doing some things about that for a number of decades, we've actually only just scraped the surface in terms of the parameter space to search, the number of stars, the number of possible radio frequencies, the sensitivities that we have to reach, and so on and so on. We know, and this has been discussed quite vigorously in recent years by scientists, by astrophysicists and astrobiologists, that we've scraped the surface. So saying that we haven't heard anything yet doesn't tell us very much at the moment. So I guess I do tend to veer in the direction that there probably are a bunch of other species just within our galaxy alone. There could be a lot of them. The reason we haven't found them yet or heard from them is that it's difficult to do that. And there's a timing question. It may be that species only have a brief window of time, technological time, where they are transmitting loudly enough or they're even bothering to listen. And once that window's gone, they may appear very quiet, no matter what they're up to out there. But as with all things, that's a instinct of mine. It's not it's not a robust scientific statement. I think the constraints that we have to make that evaluation, to say what the probability is, are still very poor, which is part of what makes the field of astrobiology so interesting. Is that we're still at a stage where we're looking for the ways to improve our confidence in these kinds of statements, and discovering planets around other stars makes a big difference to that. And I think we're going to see a lot of progress in the near future.
Give us a sense of what you're working on right now. What is your what project are you immersed in at the moment?
Well, I work on all sorts of stuff. One of the projects I'm working on quite right now, which I'm quite enjoying, I'm working on with some very talented students, is a project to build a computer code that simulates the dispersal of material from planets when they get hit by asteroids or comets, which may not sound terribly exciting, but it's an interesting mechanism that allows planets to actually share pieces of themselves with other planets. So here on Earth, we find bits of Mars in Martian meteorites, and those Martian meteorites originated because an asteroid hit the surface of Mars a few million years ago, spewed things into space, and some of those pieces of the surface of Mars have ended up here on Earth. They've been transferred through orbital space to land on the Earth. So what we're doing is building a quite sophisticated computer model to model that kind of dispersal of material, but not just in our own solar system, in exoplanetary systems, in some of the new planetary systems that we've discovered in recent years. Because we think that in some of these other systems, that process could be much more efficient. And that's kind of interesting because it allows quite old, evolved planets to mix their chemistry together and to conceivably even exchange biological material. And one of the neat things we've just found with this code as well is that it turns out that through a process of gravitational scattering and evolution, you can actually have pieces of planets that not just spinning around the star in the system they originated in, but they can leak to interstellar space. It's a very low probability, but it does happen. And that actually means that somewhere out there, there are going to be leaked pieces of the Earth and of Mars that are out in interstellar space. And conceivably, eventually, they'll intersect some completely different planetary system. So I'm quite excited by this because although it sounds a little dry, it's a neat bit of computer coding. You run these simulations on large computer clusters, and you can simulate millions of particles over hundreds of thousands of years to see what they do. And we're trying to figure out how to bring that back to also understand more about our own solar system. Because there may be places in our own solar system where there are repositories of material that was ejected from the surface of the Earth at any point during the last 4 billion years, and it's still out there. It's like a record, a history of our own planet just encircling the sun if you know where to look. So that kind of work, it feels like a long way from messaging extraterrestrials, but it's actually all part of this grander effort in science at the moment to piece together the clues to how life happens, where it goes, how planetary systems evolve, and what that evolution means for living things.
Caleb Scharf, it's so great to talk to you, and I can't wait for your next piece of Nautilus.
Oh, well, thank you. I look forward to writing it.